Right, I'm going to talk a little bit about this model diesel engine starter and another problem I've had. So let me get this off here if I can. Which way do I want to be turning it? Oh, this way. The one with this road is one that the teeth broke off this pawl. Well, they broke off the pawl, the tooth broke off the pawl, I think I showed you in the earlier video, but also the teeth broke off the ratchet. You can see the infill there. So there's the infill. So what's happening there is that I wind it up on that big spring there, big clockwork sort of spring. Pull, when it comes to use it, that locks on the ratchet, the teeth lock on the ratchet. Okay. As you're winding it up, there is a spring goes in there which I've got to talk about, that's another fault. And then when I pull the pawl, it's a bit awkward, oh it's all the way thingy anyway, I wonder it won't move just about, then it releases. The trouble is here, as this is spinning, it's got an awful lot of power in, and if I let go of this, because it's on a spring, it moves forward, it whacks against the tooth, and then it breaks either the tooth off, not always, but sometimes it might, just as it catches it, or it breaks the tooth off here. Okay, now I've printed that was at 30% when it broke, this was at 30% infill when it broke. Since then I've printed this out at 100% to give it strength, and this out at 100% to give it strength. That's about a 12-hour print, that. Just that part there. And it's not so bad, about an hour and a half. But even then, this is just PLA, so it's not the ideal plastic, really. But that's all I can afford on a very tight budget here. I thought of oh well, let's talk about the spring. Is what I found also is that sometimes the spring must jump out. It does have an indent in here, in the back of here, and it has an indent in this part as well, and the other part that goes on top. So this spring, if I can get it in, basically goes in like this. Sorry if that's going out there. Goes in like that, and then it should press and move forward the pawl as it's going over the teeth. But as I say, if you let go of that while it's spinning, it's going to push forward and it's going to catch on the teeth of the ratchet and possibly break one of the tooth off here. Even if it's probably printed at 100%, it's not going to do it much good. Or break the tooth off here, because there's an awful lot of power in this spring. And what I sometimes found is, when doing this, is sometimes this pawl seems to stop working and this spring has come out. It's been laid sideways like this. Okay, so I'm looking for another type of spring now. Obviously it's possible to do plastic springs, but that's going to probably have to be quite a bit bigger to get the number of coils in and such like, make this quite a bit bigger, which I don't want to do. But I'm going to have a look for another spring that I think might fit in here, or I might have to make it slightly bigger to get that spring to fit. I'll talk about that in another video. But what I was thinking of doing is putting some sort of catch on this, so that when you pull it back to start it up, it locks in position. So when you pull it back to start it up, it locks in position, and then you're having to press another button to release it and let it go forward. That will probably be better than this. So that's going to be the next iteration of this, doing that. Apart from that, it seems pretty good, very powerful. Look at my other videos, you'll see. Okay, so that's an update of the next stage. Is to work on a design that will latch this in position on the way back, yet not latch it as it's moving backwards and forwards on the ratchet teeth. So just have a look at that again. So obviously he's whacked against that and knocked it off, that one tooth. That, but as I say, that was 30% infill PLA.